Hi everyone, this is Sharan here. Welcome to my channel. In the last session, we saw the concept behind and logistic regression. We saw why and linear regression can't solve a problem which needs to be solved by logistic regression. What is an sigmoid function? What is the log likelihood function? How it is useful in identifying the weights? And what is the mathematical equation? And what is the reasoning behind the equation? How it helps in making the prediction? As well as how do we measure the accuracy of the model using confusion matrix. So today in this video, we are going to see an actual implementation using Python, how the logistic regression model is implemented. First, we will pick up a very simple example where we are going to pass on various inputs. It's going to be just 10 records, and we are going to see how the predictive model can be built. And then we are going to pick up a data set from kaggle. And we are going to predict whether a particular person will have a heart disease or not, depending upon the various attributes that are provided to us. So now let's get into the tutorial and then see how to implement a logistic regression algorithm. So if you are learning data science here, and if you find all these videos very useful, please subscribe to my channel. I not only post tutorial videos, I also post various videos related to various data science topics. And I also do write various articles in Medium. So I will provide links to some of my popular articles and have a look into it. Let's get into the tutorial now. So as you see in my screen, first one is we need to import various packages that is required. So first one is we are going to make use of Pandas, NumPy. We are going to make use of few visualization libraries. So in this case, just a C1, and we are going to make use of some functionalities from sklearn. So we are going to use a logistic regression, the model that we are going to use in order to make the prediction. And we are going to use the functionality such as accuracy store and the confusion matrix, which will be used to measure the accuracy of the model. And finally, we are going to use a train test split. So this will not be useful, like a train test split is not useful for this particular example, the first one that we are going to see today, because it's just few records, and then we are going to see how it works. So first, let me execute this and import all the required packages. Then we are going to create a data set. We are going to create an array which will be used in order to make the prediction. So here I'm going to use two arrays. One is the credit store, as you see, and the second one is the loan status. And I'm going to use these two data sets and convert that into a data frame. So this is how the data would look like now. So these are all the various credit stores, and this is the loan status. So here in this case, loan status is the column that we are going to predict, and the credit store is the input. So in other words, loan status is the dependent variable and the credit store is the independent variable. So then we are going to make use of scatter plot to see how the data is distributed. So here, as you see here, the values will be either 0 or 1, and then this is the credit store. This is the independent variable. So after a certain point, we can see that the value for loan status becomes 1. So as the credit score increases or improves, then the probability of loan getting sanctioned is higher. And so then what we are going to use is, this is what we are going to predict the loan status, whether it is approved or not. So first we initialize the logistic regression model. So we are going to go with the default parameters. So it's just logistic regression, and then we pass it on to a variable called as model. So then we are going to use fit in order to train the model. So we are going to pass on the various inputs as well as the output that is available for that, for those inputs. So then let me run this and train the model here. So now the model has been trained. So now the next step is making the prediction. So here in this case, what I'm going to do is I'm just going to pass on few values as input and then see how the prediction is. So here I'm going to pass on three values, 390, 570 and 770. So these are all the values for credit store. So for these values, how the prediction is. So first what I'm doing is I'm going to pass on these as an array, and I'm going to convert that into a data frame using data frame functionality, which is Pandas functionality. And then I'm going to use model.predict in order to make the prediction for these three inputs, and the value of the prediction will be stored in predicted status. So let me execute this to see what is the value that is getting predicted. So as you see here, the value for the first two is 0 and the value for the third one is 1. So for a credit score of 770, it says that the loan will be sanctioned, whereas for the rest, the other two, it says the loan is not sanctioned. So which is quite understandable from this particular scatter plot here. And then finally, measuring the accuracy. So this might not be much relevant here. So let's not maybe execute this. So this is a very simple example to see like how a predictive model would work. So first one is we convert that into a data frame into a format which is usable. We then initialize the logistic regression model, and then we use the model.fit in order to train the model. So while training the model, we pass on the known inputs. We pass on the values for the independent variable as well as the output of the dependent variable. So the model would be trained based on those known values. So once the model is trained, so then we use model.predict in order to make the prediction. So here in this case, we pass on a specific value to see how the prediction is. So that is a simple example. So now let's move on to an maybe more of a real life example. So here, first let me execute all the packages that will be required for today. So the one additional package or functionality that I'm going to use is train test split. So here in this case, we have various inputs. So we are going to separate that into a training data set and test data set, so that we can train the model using the training data, and then we can test it using the remaining data set, and then we can measure how good the model is using the accuracy score as well as the confusion metrics. So this is the data set that I am using, the heart disease prediction. So if you want to make use of this data, you can refer to the data repository, which I will be providing you the link in the description. So you can find all these strips, all my strips all updated in my data repository. So let me execute this so that I can read the data. So here in this case, what I have done is I have downloaded the CSV data, and then I'm just directly reading it from there. So this is how the data will look like. So it has various attributes, all these independent variables, and then finally this is the dependent variable that we are going to make use of to predict. So first one is I'm going to drop off all the NAs, because if there is any missing values, that could be a problem for us. So we are not going to see about how to handle all these missing values. All these have been covered in exploratory data analysis. So I'm going to just assume that I'm going to drop off all the NAs and there is no missing values. So let me execute this and then just remove all those missing values here. The next one is I'm going to move all the independent variables to X and then the dependent variable to Y. So I'm going to make use of this in order to segregate both of them. So now both has been separated. So then what I'm going to do is I'm going to use train test split in order to generate the training data set and test data set. So generally the training data set will be maybe 70 to 80%, and then the rest would be the test data set. So here in this example, I'm making use of 20% of the records for test data set. So once the model has been trained using the training data set, we will use that model to see how good it is predicting for the rest of the data. So let me execute this so that the test and training data set are prepared. So then the first one is I'm going to initialize the logistic regression model. So I'm just going with the default parameters. I'm not tweaking anything. So I'm just going to initialize it to model 1. So then I'm going to use model 1.fit to train the model. So here X train and Y train are the values for which for these independent variable values, this is the Y value, the value which is whether the particular person has a heart disease or not. So let me execute this so that we have trained the model. So now the model has been trained. So then what we use is we use model 1.predict, and then we pass on the test data set. So the test data set is the independent variables. We are going to pass that as an input so that the output can be predicted. So output, it will be predicted and then stored in y_pred1. So let me execute this. So this is our actual prediction. So once the prediction is made, so then what we can do is we can use the confusion metrics as well as accuracy score to see how accurately we were able to make the prediction. So let me execute and then show you. So as you see here, the prediction score is about 86%. So 86% of the times we are able to predict the value correctly. So if you see the confusion metrics, as I said, the true negative and true positive seems to be higher, but here the problem that I am seeing here is the value for true positive is very less. We are able to correctly identify only 3 values, whereas a majority of the value is as is drawing here. So even though the accuracy is quite high, so I can see clearly that the true positive representation is very small. So now what I'm going to do is I'm going to make the prediction again, but I'm not going to go with the default logistic regression parameters. I'm going to pass on few additional parameters. So as you see here in the screen, so I'm going to pass on the solver, like what is the method that needs to be used in order to solve this logistic regression problem. So I'm saying that I need to use lib linear method in order to solve this, and then I'm passing the value 16 to C. So value C represent the regularization. Like we pass on a value to it, and then we also say random state should be 0. So let me pass on these values, and then what I'm going to do is I'm going to use the same data set. I'm going to use the H train and Y train in order to train my data set using model2.fit, and then I'm going to make the prediction using model2.predict and pass on the values to y_pred2. So then I'm going to make use of the confusion matrix. So if I'm going to see how good my y_pred2 is as compared to the actual value which is stored in y_test. So let me execute this, and then so as you see here, the value has been slightly improved. So it's now 86.2%. Previously it was 86%, and I can also see that slightly the true positive has also increased from previous example. So as you see here, we can tweak all those parameters, and then we can make use of the various exploratory data analysis, feature engineering in order to improve the accuracy of this particular model further. So right now the accuracy is at about 86%. So the exercise for you today would be to identify another data set which can be used for logistic regression. So you can make use of the Titanic data set as well, and you can predict you can predict the survival. Also, what you can do is you can make use of the same data set that I have used today, and then you can use various exploratory data analysis and feature engineering techniques that we have studied in the past, how those can be applied in order to improve the accuracy of the model. So that's it for today. If you have learned something new today, please give a thumbs up, and if you are able to improve the accuracy of the model here, so then in the comment mention what was the accuracy to which you were able to reach for this particular data set. So that's it for now. See you in the next session with another video. See ya. Bye.